Hi everyone. Today we're going to study derivative of a function and we will see some sample problems. Let us first state the definition of derivative. The derivative of f with respect to x, denoted by f prime of x, is defined to be f prime of x equals the limit of f of x plus h minus f of x all over h as h approaches 0, provided the limit exists. Let us see this example 1. Find the derivative of f of x equals 5x minus 2 using the definition. Let us write our formula for derivative here. And for our step 1, let us evaluate f of x plus h. Considering our function here, we're going to change every x by x plus h. So we have now the f of x plus h equals 5 times the quantity x plus h minus 2. Simplifying this, we have now 5x plus 5h minus 2. For step 2, let us now evaluate the limit formula of derivative. So we write here f prime of x equals the limit of 5x plus 5h minus 2. This comes from our step 1, and this is our f of x plus h. Then minus f of x. This is the given function, the 5x minus 2. So we write it here, all over h, as h approaches 0. Let us simplify by removing the grouping symbol of our numerator. So we have now 5x plus 5h minus 2 minus 5x plus 2. We can see that some terms in our numerator can be simplified or combined together. Look at this 5x. We have negative 5x here, so they zero out each other. The negative 2 and the plus 2 will be 0 also. Writing again in simplified form, our function now becomes 5h over h. The h and the h can also cancel out. Our function now is simplified into a constant 5. So the limit of 5 as h approaches 0, and we have our answer, which is 5. This is our final answer. This is the derivative of our function. Let us see this example 2. Find the derivative of f of x equals the fraction x over x minus 1 using the definition. For our solution, we write again the limit formula of derivative, and then our step 1 is to evaluate f of x plus h. This is equal to x plus h all over the quantity x plus h minus 1. We can simplify our fraction here by removing the grouping symbol. So we have now our new fraction here. For step 2, let us now evaluate the limit formula of derivative. So we write here f prime of x equals the limit of this f of x plus h, and we copy this fraction in here, minus the f of x is our given function, so we copy it in here, all over h, as h approaches 0. We can see that we have a complex fraction here. Let us simplify our numerator by multiplying this fraction first diagonally down here, and then minus this denominator we multiply by our numerator of the second fraction all over the product of the two denominators. So it will be like this. While the h in here, we will flip it up and we write here times 1 over h. Now, let us simplify our numerator by multiplying the corresponding factors. So we have here x squared minus x plus hx minus h minus the quantity x squared plus hx minus x. Now let us remove the grouping symbol and let us see if we can combine some terms. So it will be like this now. Please observe that this x squared has a counterpart of negative x squared here. It becomes 0. We have negative x and positive x. It will be 0 also. The positive hx, and we have this negative hx. If we remove those terms, we can simplify our fraction here into simply negative h. This negative h in our numerator now and the h in the denominator can cancel each other. So writing again our fraction, the simplified form, into negative 1 all over this denominator. Now let us evaluate the limit as h approaches 0. It means we are now to substitute 0 to this value of h. Here we go. Simplifying further, we can now remove the 0 and we can see that this is now negative 1 all over x minus 1 times x minus 1. We can put the factors together using exponent. So our final answer is negative 1 over the square of x minus 1. This is the derivative of our function here. Let us see example 3. Find the derivative of f of x equals the square root of x using the definition. We have here again our formula, and step 1 is to evaluate f of x plus h. So we have here f of x plus h equals the square root of x plus h. Step 2, to evaluate the limit formula of derivative. So we have now f prime of x equals the limit of the square root of the quantity x plus h minus the square root of x all over h as h approaches 0. Let us now simplify our fraction here. Please remember our special product formula that a minus b times a plus b equals a squared minus b squared. We said that the factors here are conjugate of one another. So to simplify our fraction here, we want to remove the radical. So we're going to multiply this fraction by another fraction whose numerator and denominator is the conjugate of our numerator here. So we have to multiply this by square root of x plus h plus the square root of x. Take note, this is negative, so we write here positive. So the numerator here is the same with our denominator. When we multiply now these two big fractions, in the numerator, we're going to apply our special product formula. While in the denominator, we will simply put together the two denominators. So it will be like this. The limit of the square of the quantity square root of x plus h minus the square of the square root of x all over the denominator is simply putting together the h and these big radicals. Now, let us cancel out the square and the radical sign. And let us write again the fraction here. So we have now the limit of x plus h minus x all over our same denominator. We can see here that in the numerator, the x minus x becomes 0. So only the h remains in our numerator. Please observe also that there is an h in our denominator. So we can cancel the h and the h respectively. Simplifying further, we can now write the limit of 1 all over the square root of the quantity x plus h plus the square root of x. Now, let us evaluate the limit as h approaches 0. Let us substitute the value 0 to our h here. So we have now 1 over the square root of x plus 0 plus the square root of x, that we can show that this is equal to 1 over the square root of x plus square root of x. We can now put together the square root of x into 1 over 2 square root of x. This is our final answer. This is the derivative of our function here. I hope you learned something from this video. See you again next time.